Hey, what's up guys, my name is Cherno and welcome to the 5th Sparky devlog. So, last week we took a look at SPM tool or SPM build tool and how models kind of work with in Sparky, and I of course added that whole custom model format. And I began to show you guys where I was at with physically based rendering, and I kind of showed off this demo. I didn't really say much, but today we're going to dive pretty deep into that. We're going to see exactly what I did with that. I'm going to update you guys with what I'm currently working on, of course, in typical devlog fashion, and just kind of cover what I've been working on the last 2 weeks. So the first thing I want to do is probably talk about well, I mean, I guess we'll start off with yeah, I think I'll just kind of start off with PBR here, and we'll see how we go with all that stuff. So the first thing that I wanted to mention was I think since the last devlog, really, I think it's been almost a month actually. I've pretty much been if you do take a look at the GitHub repository for Sparky, you won't see any of these changes, and you might be surprised. You might be like, well, where is all of this code? Why is it when I download this version of Sparky, I don't see any of this physically based rendering things? Like I open test 3D and this is not what I see. Why is that happening? Well, glad you asked. The reason is that I'm actually not using Git for kind of really kind of fast iterations, and really like when I'm actually developing things all the time, like when I'm actively working on a new feature, instead of creating a branch in Git like I used to do in the past, I actually use a separate version control system called Versioner. Okay, that's why you're not seeing anything here. So I kind of showed you guys this last time, or the time before that. Like if we go over here, we open a command prompt and we take a look at the log, the concise log, you can kind of see what I've been doing, right? So this isn't even let's limit this to like 20 or something. This isn't even that recent, but like if you look at the dates, yeah, so basically all of February really I've been working on all of this kind of stuff, right? So I finished the image-based lighting function. We have all this kind of PBR work that's going on. Normal mapping got added. A bunch of really quite interesting features, right? And I commit these to Versioner because there is no reason for these to be public, okay? These are kind of really like this is like my development cycle, right? I also find Versioner a lot easier and more reliable than Git, to be honest. And that's kind of the reason that I use it. It also handles large files very, very well, which is going to soon become a problem when I start actually adding resources, as I am now, in fact. Now, initially, my plan was just to leave it at that, but you guys wanted me to somehow give you access to this. So what I'm doing is I'm setting up a pretty exclusive server that has all this stuff in it, right? All of my kind of broken nightly building, and like you can see these commits are like, what, it's like 4 commits a day. This stuff is pretty frequent. And all you have to do to get access to that code is support Sparky on Patreon, okay? So if you go to Patreon and you pledge $5 or more per month, then you get access to this Versioner repository, okay? And you can take a look at all the code when it's still being developed by me, okay? Now this isn't for everyone. I probably wouldn't recommend this for people who just want to jump into Sparky and actually see stuff working. But if you want to be on the bleeding edge of things, you want to kind of see all this stuff that gets added, and of course it is a repository, so you'll be able to see what I remove as well. If you really want to keep up to date here, then that's going to be your best bet. So this is only for people who really want to kind of jump in and follow Sparky very, very closely and support it, okay? If you guys don't want to do that, that's absolutely fine. It'll still be on GitHub. I'm planning a release soon on GitHub, so I'll update all of this stuff onto the GitHub repository. But you can see right now that if I actually do check for modifications or something in Git, like a lot of things have been modified since I last Git committed. Like look at all this. Look at all this. That's not even including stuff that I added. Like all of this stuff. This is all new. So yeah. If you guys want access to that, then Patreon is the way to go. Okay, cool. that also kind of gives me some support as well. Obviously, the reason I'm doing that is because I want to spend more time working on Sparky, and with your support, that is very, very possible. Okay, cool. So let's focus on physically based rendering. The first thing I want to mention is that people have been begging me for quite a while now to actually kind of show you guys in my old kind of tutorial fashion how to implement all this stuff line by line, okay? And my answer to that is I am totally going to do that, okay? Once I get it down in Sparky, okay? Just drinking some water there. That's the important kind of part of this, right? I will do these tutorials and I'll teach you guys how to do this line by line. I'll explain how everything works, but I really want to get this right first in Sparky because I'm still experimenting with it, right? I don't have a full PBR implementation that I can just slap in right now. Yeah, I'm still kind of working out what kind of values I want everywhere and what particular models I actually want to use, okay? So it's a bit difficult for me to do that because I definitely am not comfortable with teaching something that I'm still very much researching. So that's why you guys aren't seeing that. So I am kind of focusing on Sparky right now, as you can see. And then once I'm 100% confident in my ability to implement PBR, I will start making videos on how you guys can implement it for yourselves, okay? Definitely gonna happen, so don't worry about that. Okay, cool. So, let's start off here with the top and we'll kind of go through this test 3D thing. It's about 300 lines, in fact it's exactly 300 lines. So it's not the smallest demo, but it definitely has a lot of redundant things in it, so don't worry too much about that. Okay, cool. So let's see what happens here. So it's broken down into a few methods. Yeah, every kind of layer has these methods. Okay, whether or not you actually implement your own versions of them, so you override them or not, that's your choice. But basically, we have on event, on init, on render, on tick, and on update. Okay, and then the constructor and destructor. So the idea is the three ones that we kind of care about are on init, on render, and on update. All right. On event is useful for doing like key events and stuff, but like we're not even doing that stuff right here anyway, so it doesn't really matter. Okay, cool. So yeah, so with those three methods though, on init is where we kind of initialize the game. If I can remember the shortcut to collapse everything, I think it's one of these here. No, maybe it's control. What is it? Oh man. Trying to remember, isn't it Control L, Control O? Maybe it's Alt. All right, I don't know. There was a shortcut that I've totally forgotten, which just basically collapses all the methods for you. Anyway, so yeah, so on init will kind of run when the layer gets initialized. So this will happen once. Think of this as like the constructor, except it will actually happen when there is a renderer and a scene already created. Okay. On tick is something that runs once per second, so it's really just useful for printing out stuff like frame rate. Okay, we don't really need to be doing this, especially because we are displaying it on the actual thing, but that's fine. On update is something that runs 60 times per second, no matter what your vsync is. And then on render is something that runs in sync with your monitor's refresh rate, right? So 60 hertz or 60 frames per second would be kind of the amount of times that would get called on my monitor. Okay, cool. Whether or not that vsync is actually accurate, I'm not 100% sure. I don't think so. I think it's just set to 60. It's just hard coded in there. But future proofing that is how often on render will happen. So cool. And then on event, of course, gets called whenever an event gets triggered that hasn't already been handled by another layer. Okay, so jumping into this. The first thing we do here is we basically load in a cube map, okay? This is actually not the cube map we're using anymore. I can probably get rid of that. This is the cube map that we're loading. Now, if we take a look at this, we open the containing folder here. In fact, I think I've already got this open. We can take a look at the resources that we have here. So this is on the PBR cube map. So we'll go into there. And what you're seeing here is 11 cube map images. Okay, they're BMPs for no particular reason, but basically what these guys are, if I just open this up, it's gonna, I really wanted it to open in paint.net, but Oh well. If we open these up, I'll open all of them up. Might as well show you guys what's up. Oh, that's totally not what I wanted. Cancel. Anyway. Why did that not just open them all as separate? There we go. Okay, so, basically what you guys are seeing are mip maps, okay? So this is in a vertical cross format. Basically, this is, where's my selection thing? This is the kind of Y positive cube map. This is the Y negative cube map. This is the X negative, X positive, Z positive, and Z negative. Now this one's actually flipped. It's kind of upside down. So this one actually needs to be flipped both horizontally and vertically when you load it in. But anyway, the idea is what we're seeing here is a cube map. Now, where did I get this cube map from? Well, that's a great question that I wish I could answer, but I'm not sure. Let's quickly just see what. Now, again, this is something that I will go into in depth in a dedicated video, so that you guys can know how you can make your own cube maps and all that stuff for Sparky. So I did tweet someone the link though, so I'm just going to quickly find that tweet. Yeah, here it is. So it's a really quite a good resource called hdrlabs.com, and what you'll find is it's called SIBL, right? As they call it, Smart IBL. But basically, there are free HDRI sets for image-based lighting, right? So if we quickly look at this, and I'm actually uploading a video right now, so that's why my internet is extremely slow, because I'm using like all my bandwidth. So I'll take this opportunity to drink some water. This is going to be quite a long devlog, because I want to kind of show off the stuff that I've been working on. So hope you guys are okay with that. All right, so this has a lot. There are quite a lot of cube maps here. Now, when you download these, they actually, first of all, the thing you'll notice is they are huge, yeah? You can see this one, as it says over here, the resolution is 8,000 by 4,000, okay? Absolutely massive, which is great. One of the things that you'll notice is they're actually lat long images. So what I mean by that is, I would download one now, but my internet is terrible. Basically, HDRI. Basically, they look like this, right? I'm actually not even sure if they're specifically in lat long, but they kind of look like this. So they don't come in a cube map form, okay? So you've got a few options. The best option is to just find actual cube maps, but this is a good example of the different formats that you'll find. So spherical is one name for this, although spherical can be confused with kind of the light probe spherical, because this is literally a sphere. But lat long or latitude longitude is a good kind of thing. So this is what format those maps will come in. We want them in a vertical or a horizontal cross, right? They can also be separate images for Sparky. So in order to do that, you have to convert it from this format to this format. Now, you will lose a little bit of data by doing so, but not enough to really notice. Because remember, this is just a cube map. It's not really it's not like a texture that you'll full on view. I mean, obviously, certainly possible if you were reflecting everything like a mirror. But anyway, the point is, you can convert this. Now, I'm using a tool called CMFT for that, and CMFT is right over here. It's a cross-platform open source. It's a little command line utility. It's got a GUI as well, but I personally don't like it. Basically, cube map filtering tool. It's very, very fast. It will convert it'll convert the lat long HDR kind of images into cube maps for you, into like vertical cross cube maps. It can also generate mip maps. I haven't really experimented with this generating mip maps, but I have been using something called Cube Map Gen, which is an ATI kind of AMD little utility from a long time ago that will basically take in it'll take in the vertical cross that CMFT will generate, right? And it will produce mip maps for your cube map, so that instead of looking like this, where you can see the seams of the cube map, and I'm not sure if I showed that the devlog before last. I don't think I did, but basically, if you just mip map them yourselves or get OpenGL to generate mip maps for you, in fact, I can probably show you what that looks like if we bring back those ones and we say that environment equals texture cube from files. So files and yeah, so that should, we'll see what this does, if it even works. Okay, cool, it did. So this is a different cube map, but basically the problem with this one is that it's not mapped properly. So whilst these ones will kind of look okay, and that is, like, I've been seeing this a lot, this kind of white specular. I don't know what that is because the specular is like up here. Anyway, you can see what this looks like. Yeah, it looks absolutely terrible at low MIPS, okay? And that's because obviously if you're looking at something that is literally a 1x1 cube map, if all faces like different colors or whatnot, it will look terrible. So what you need is you need to properly filter your MIP maps, okay? You can use something like the AMD tool, right? The cube map gen, that'll do it for you, okay? You can load in that vertical cross that you get, but possibly CMFT will do it for you as well. I will experiment with that more throughout the week. But the idea is, you can see how disgusting that looks versus something like this, right? Which looks much, much nicer, okay? There are still a few visible seams, but I actually tweaked none of the settings in the cube map gen at all. I just literally press filter and export because I didn't have too much time. But you can see already it looks a lot better anyway. Okay, cool. So that's kind of the idea behind cube maps. Again, there'll probably be an in-depth kind of video about them. But that's just all you need to know about how they work. And that's why I have separate MIP maps. Yeah, you can see that texture cube from multiple files, that just calls GL generate MIP map, which is kind of okay for textures, like for just 2D textures. But of course, cube maps, when you have lower MIPS and you're sampling, you'll get corners and you'll get those seams. So it's not really something you want to do for that. And so you can see that what happens here is when we load it from the cross thing, we kind of set each MIP separately, okay? So that's something that happens there. Okay, cool. So then we create a bunch of materials. Let's take a look at what the materials actually look like. I'm using something called Quixel, which is a Photoshop plugin that I will probably show you guys how I use that in some other dedicated video. Man, this is going to spawn off so many videos. I'm sure you guys will be happy seeing them. But let me know if you are hyped for like videos on like 10 different subjects. So if we look at something like cast iron, that's probably not a great example. Let's look at something like worn wood, okay? So what we have here is a bunch of maps, okay? You can ignore the gloss 8-bit for now. So basically we have a PBR material is made up of usually around 4 textures. It can be a lot more. But we in Sparky are currently using 4 textures. Those are the required ones, okay? You don't really need to have them. I've always developed Sparky with the mentality of it should be easy to use. Thus, as soon as someone wants to quickly create like a sandbox kind of thing and they just want to see a cube, they shouldn't have to go out and make 4 textures for it to even render, okay? That's silly. So there are kind of 2 options. There are defaults, which don't exist yet, but there will be defaults for pretty much everything. But other than that, you can either set a texture or a color, okay? So you can set a constant color as like one of these PBR textures, right? So if you want, like, say the entire specular to be a single color, you can just set a color. You don't have to set a texture, okay? Or you can set a texture if you want to, okay? So the ones we're seeing here are, so the albedo looks like this. The albedo is diffuse, okay? That's what albedo means. It's just the diffuse color. So this is the kind of color of the surface, so to speak, right? This is what it looks like for this particular material. If we look at something like what gunmetal looks like, and again, these are all materials generated from Quixel, which is a very, very good little utility, which I definitely recommend because it's kind of like Substance Painter and Substance Designer, I guess. But a lot easier to use, and it's great for quick materials. You guys probably have no idea what I'm talking about, but basically what Quixel is a plugin for Photoshop which will kind of generate these maps for you, and they have like 100 presets, okay? And this is one of them. So that's kind of where I'm getting these from, okay? I'm not making them myself or anything. But when the page loads, you'll kind of see what Quixel is. Man, multitasking today, uploading a video, recording a video while it's uploading, ends up with a really, really slow internet, which is fun. That's what it's like to live in Australia, where our upload speeds are horrific. All right. So this is what Quixel is. I'm actually just gonna probably not. Yeah. Not that this really shows you what it is, but this is what I'm talking about. Okay, Quixel Suite 2. So you can use something like DDO Painter, or DDO Painter, and 3Do or 3DO, which will kind of just preview everything for you. But basically, you can select from a bunch of presets and then generate textures from them, which is what I've done. Okay, cool. And then again, there'll be a standalone video for that eventually. All right. So yeah, if we look at gunmetal's albedo, for example, you can see that it's just completely black. So it's just a solid color. It's not really. You can see there are a few scratches in the texture, and that's fine. So that's the albedo. All right. If we were to, I might actually just, if I pop over into my shader, I could just show you guys these things kind of separately. So if I just set the color to the albedo, then you'll see the albedo of every kind of surface. Okay, so you can see that there are a lot of kind of black albedos out there. I'm not using anything like worn wood anywhere. If I was, you would see that albedo. So if I change that cube to use worn wood, then you can see that that's kind of that albedo right here. All right. Cool. So if we look at the next texture, so where are we? Paint.net. Okay, the next one that we'll probably look at is specular. The specular map is sorry, that's for gunmetal. That's what it looks like for gunmetal. This kind of will just define the specular color essentially. So if we go over to where am I? Wornwood. Specular. All right. You can see this is, I'm pretty sure this is just a solid color. So having a kind of having a low kind of specular color, so you can see obviously this color is like, what is it? You know, it's quite dark, right? It's something like 46, 46, 46. So that will result in kind of a dimmer specular, right? So again, if we kind of view that for everything, material specular, which is a vec3, then that's kind of what we are seeing, okay? And we'll talk about the plane probably later, but you can see the specular colors of all of that. One thing that's cool to note is you can see that the plastic balls have a low specular, whereas the metal balls have a high specular. That's kind of how metal works in the real world, basically. So metal will have a very, very black kind of albedo. I say very black because it's not completely black, but a very, very black albedo and a very white specular, okay? And these are actually just constant values for the spheres. Here they're actually maps, right? They're textures, but here they're constant values. Cool. So that's good. And you can see, by the way, that if like we can change these a bit later on, and I'll show you how that works as well. I guess we'll look at the gloss, which is really just one channel. You can see that it's very, very low here. It's got kind of color variations, right? But it's very, very black, which means that the surface is not reflective. So if we look at the roughness, so roughness is basically gloss. It's basically 1 minus gloss, right? That is what roughness is. So it's just the inverse of gloss. So roughness is what I use in all my equations. So if we look at that, and I'll just set let's see. This is a bit annoying, but we'll do something like that. Just want the alpha to be 1. Then you can see what the roughness looks like. So there it's fine. This is white, which means it's completely rough, and you can see obviously the varying roughnesses of these balls. All right, cool. That's our roughness map. So that basically defines. Over here is actually a gloss map, so this is actually 1 minus roughness, right? So basically, if something's black or if something's dark, it means it's not very reflective, okay? Whereas if something is white, if the gloss map would be white, then it would be quite reflective, all right? And you can see that roughness eventually is used in primarily, well, it's used in the specular equation, but it's primarily kind of important for stuff like IBL as well, because it defines, for example, which MIP level we sample. Because basically the idea is the more rough a texture is, the kind of lower resolution copy it gets of the world because it's reflecting less. Anyway, not going to go into the theory here, but the idea is that's what our roughness is. And then finally, we've got the normal map. All right. And a normal map is pretty basic. Okay. It essentially all it is, of course, is just a modification to our vertex normals, right, to give a bit more detail. And that, of course, is just used in light equations. The color determines which way the normals are facing for that particular fragment. So if we just look at that, not that that is probably too interesting, but we actually can't even look at that because, oh, well, maybe we can. We can look at the normals that it generates. So there we go. Whoops. There is a semicolon in there. All right, so these are the normals that we kind of get as a result of that normal map. All right, you can see them there. Okay, cool. I think the same normal map is being applied to pretty much everything except for this cube. All right, cool. So that is all the different maps. And if we render them all together using that worn wood kind of thing for that cube, then you should see something that looks a little bit like wood. Okay, I've actually turned off the normals though. Which is why everything is very, very smooth. But this is basically wood. It's supposed to be wooden. Whether or not it is probably dependent on my actual calculations, which I have not proofread 100%. I'm not 100% satisfied that they're actually correct in my shader. So I definitely need to spend more time there. So don't yell at me if something doesn't look quite like it should, because it's very possible that that will be the case. But if we put the normal map back on, perhaps this will look a little bit more like wood. So yeah, I'm seeing kind of some really bright areas which do look a bit weird, which I still need to probably work on. But anyway, it kind of looks like a wooden block. I wouldn't argue too much with that. Anyway, that's kind of how that works. Now, say I wanted, since I am using a, we go back to test 3D and we look at the actual material that we're using for that block. I think that, yes, so basically we set up our materials. Just let me finish my first thought. We set up all of our materials and then we create a bunch of models and entities which use those materials. All right, this or these two things kind of just create our spheres. All right, and then we create that plane entity. We set up lights and shadows, which we don't actually render because I've turned that off for now. All right, cool. Then that's pretty much this entire thing. And there are a few things here that just update certain transforms because, of course, we have those debug menu hookups that we use to modify stuff in real time, which I don't think I'm using right now. But anyway, that's kind of how the rest of this test works. So when I create the cube, I create a new material instance. Let's kind of bring this out so we can kind of play around with it. So cube material, I'll call it. So we have our material instance called cube material. How long is this going so far? 28 minutes, incredible. All right, we've got this cube material. We can kind of override certain things. So we can say that instead of using, because what happens is this cube material, it's a material instance that gets created from a material, right? And the actual material is worn wood, is this one, right? You can see what's happened is that material has an environment map and four kind of other maps, right? Albedo, specular, gloss, and normals, all right? So we can, of course, in the material instance, set these to other things, and it will only apply for that material instance. So if I set the cube materials albedo, you can see I can choose between an albedo map or just an albedo color. But let's do something more interesting like gloss. I can set the gloss to be 1, right? Which would mean that it's super, super reflective. And if I take a look at what that would look like, you can see how now we are basically reflecting everything. The normals are pretty up there, so you can see the reflections are not clear or anything, but we can see kind of how this is much more reflective now. Kind of like what this Cherno thing on the ground is. Very, 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 very reflective. Okay, so that's an example. The other thing we could do is actually modify the map. So if we take a look at gloss, for example, which is this one, I could just take a fairly large brush here, and that's not even that large, and maybe select white and just kind of draw something here, right? And then if I save that and we take a look at our cube again, then you can see that kind of areas of the cube look like they're very, very reflective and areas don't. All right. And then there's that thing. Now the actual UV unwrapping is probably very weird for this model because I didn't do it. Also, we are rendering back faces. That's fun. But basically, yeah, you can see kind of what I did with that map. Cool. And we can even do some probably really weird things with that, such as perhaps running a gradient through like that. Again, never tried this actually, so I don't know what this will look like, but I'm sure it'll be fun. All right, so looks like the way that the UV unwraps is kind of making this look like one face is very reflective and one isn't. It'll probably be the normals are quite kind of harsh, you can see, for this texture. So if I turn the normals off, then we'll be able to see the reflection stuff very, very clearly, as if this was a mirror. So you can see that this part is kind of gradienty. Kind of looks quite cool actually, and then this one's just not at all. You can see in the Cherno as well, we can kind of see the environment very clearly, which is kind of cool. All right, anyway, that's kind of what that looks like. What was I going to do here? Yeah, I was actually going to try and... So if we go into our custom material, I called it, which is that one that has Cherno written on it and all that stuff, and we look at the gloss. If I replaced this gloss with a gradient and saved it, let's take a look at this. I'm just curious more than anything now. It's quite fun to play with. Okay, that's interesting. So, wow, okay. So yeah, you can see this side is barely reflective, and then as we get more here, we get way more reflective. So that's kind of cool. And then I also wrote Cherno and Specular, which is why you're still seeing it. Yeah, that's actually very, very weird. Anyway, that's that, okay? That is basically what I've done over the past few weeks, or week and a half, I think. So, yeah. Still kind of tweaking it, still fixing it. But that is kind of the gist of Sparky PBR. So it's coming along nicely. Obviously needs a lot of tweaking in some cases, but more or less it looks pretty good. As soon as it does start looking great, and also the other thing we can probably do, which I should have mentioned, is we can change the light direction, and you can see how that kind of changes, of course, the specular and all that stuff. I quite like these cubes. They've got the cast iron normal mapping on them, by the way, which is the cast iron material, so it looks like this, which is pretty crazy. That's why you're seeing that. But they still look quite nice. So yeah, once I kind of wrap this up, apart from making videos on how it works, I'll probably start trying to actually create a proper scene. That probably will be a good time to start writing a level editor as well for Sparky, but that's a lot of work, so I don't know if I can be bothered doing that. I might just assemble everything in code. I'll probably end up putting something like Lure into the engine as well to make this a bit easier. I did put in reloadable shaders as well, so if you hit the R key, it will just reload your current shader. So that's nice. What else did I do? That's about it. So that's going to wrap up this devlog. Thanks for watching, guys. Again, if you do want to stay up to date with the code, then patreon.com/thecherno, there'll be a link in the description. You can get access to the version repository there. Apart from that, yeah, just follow me on Twitter. I usually post a lot of pictures of Sparky. For example, if you look at my feed recently, you can see I kind of posted all these kind of screenshots of what I was doing. And speaking of staying up to date as well, Slack is a fantastic little resource for that as well. So there's a Sparky channel on my Slack page. And if you go over here, I kind of somewhat treat this like my kind of devlog, or rather like a little blog, like a development blog. So I post like pictures here all the time, and I talk to people, and we discuss things, and it's a really good, quite a nice place to be. So if you want to join there, you just have to go to slack.thecherno.com, enter your email address, and you'll be able to join the Slack and join the Sparky channel. Okay. Of course, there are other channels for stuff like general talk and C++ and Java and all that stuff, but Sparky, of course, is relevant to the Sparky game engine. All right, guys, thanks for watching, and I'll see you next time. Goodbye.